What if a machine could turn a digital idea into a real, working part in hours instead of weeks? Not a rough model, not a presentation piece, a part you can actually use. That's the real shift happening with 3D printing. Most people still think of 3D printing as a tool for making prototypes, something to test a shape, check a fit, or impress someone at a demo. And yes, it does that incredibly well. But the bigger story is this. 3D printing is moving beyond prototypes and into end-use parts. That means brackets, housings, tools, fixtures, replacement components, even custom medical devices and aerospace parts. So why is this such a big deal? Because traditional manufacturing usually depends on molds, tooling, machining setups, and minimum order quantities. That works great when you need thousands of identical parts. But if you need one custom part, or 50 specialized ones, the economics get messy fast. 3D printing flips that around. It builds parts layer by layer directly from a digital file, so you can make complex shapes without expensive tooling. That gives you three huge advantages: speed, customization, and design freedom. The key mechanism is additive manufacturing. Instead of cutting material away, like CNC machining, or forcing material into a mold, like injection molding, the printer only puts material where it's needed. That means less waste, fewer constraints on geometry, and faster iteration. And that's why 3D printing is especially powerful for parts that are hard to make any other way. For example, internal channels for cooling, lightweight lattice structures, or one-off parts shaped around a specific machine or human body. Imagine a factory where a conveyor system breaks and a small plastic mount fails. Traditionally, waiting for a replacement can mean downtime. With 3D printing, that part can be scanned, redesigned if needed, and printed the same day. Or think about a robotics team needing custom sensor mounts for a prototype. Instead of waiting for a machine shop slot, they can print, test, revise, and reprint in a rapid loop. That speed can completely change the pace of development. In aerospace, weight matters a lot. 3D printing allows engineers to make parts lighter by removing unnecessary material while keeping strength where it's needed. That can improve efficiency without sacrificing function. In healthcare, the value is even more personal. A dental aligner, prosthetic socket, or surgical guide can be tailored to one person's anatomy. That level of fit is difficult and expensive with traditional mass production. Now, 3D printing is not replacing every manufacturing method. It can be slower per part, material choices are still more limited than some traditional processes, and surface finish or strength may need post-processing. But for low volume, high complexity, or highly customized parts, it can be the best tool for the job. So the real power of 3D printing is not just that it makes things. It makes the right things at the right time with far less friction. From prototypes to end-use parts, it's changing manufacturing from a world of fixed molds and long waits into one of on-demand creation. And that's not just convenient. That's a different way of building the world. From prototypes to end-use parts, the real power of 3D printing is just one small part of 3D printing materials and manufacturing. If you're interested, our full free 3D printing materials and manufacturing course is linked in the description.